The second generation of Apple's self-made computer chip is official, and while this silicon, named the M2, is very exciting because it will power almost everything Apple in the near future, ranging from iPads to iMacs to even the long-rumored mixed reality headset, the first product available to cons. I say boring because all the new upgrades Apple introduced to last year's 14 and 16-inch MacBook Pros, including a new design with thinner bezels and a superior display panel, somehow did not make it over to this new 13-inch machine. In fact, this 2022 M2 powered 13-inch MacBook Pro looks identical to the 2020 MacBook Pro, and the 2018 one, too. It's literally using the same components as before, just with the M2 chip, and a slightly larger battery. But while this 13-inch design feels dated, not just compared to the aforementioned other MacBooks, but also most 2022 Windows machines, too, it is perhaps what's on the inside that counts. And the M2 is a tremendous performer at this $1, $200, $800 price range that this MacBook Pro model falls into. It is at least as powerful as any Windows laptops at this price range, but it's so much more efficient. A brief recap of Apple's silicon before we continue. It's worth recapping the history of Apple's silicon for readers who may not be familiar. The silicon industry is dominated by two architecture types: ARM-based architecture, built on reduced instruction set computing, RISC, and Intel's x86 architecture, which is built on complex instruction set computing, CISC. As their instruction set implies, ARM-based silicon are less complex, prioritizing efficiency over raw power output. These are usually called systems on chip, SoC, because all the required computing bits are stored in one tiny chip. Intel's x86 architecture silicon are more complex, larger in size, capable of more power, but may require other parts to fully do its job. For well over a decade, the conventional wisdom in the computing space was that smaller, more efficient ARM chips are great for small, frequently used devices like smartphones and tablets, but for real computers, it's best to stick with the more complex x86 silicon because they offer higher PERFO. A little more than 2 years ago, Apple essentially threw that conventional wisdom out the window by announcing it was ditching Intel silicon in favor of its own chips built on ARM architecture. It stunned the computing industry, and Apple delivered. The Gen 1 chips, M1, came out in late 2020 and surprisingly was able to power Apple's portable and desk-bound computers fine, and it was significantly more efficient than Intel-powered laptops. The second generation now comes the M2, which Apple claims offers an 18% CPU improvement and 35% GPU improvement over the M1, and whether it was benchmark tests or real-world tests, my M2 MacBook Pro did indeed deliver those performance gains.